your I guess the score also will be released, I guess, in upcoming 2 days, maximum 1 or 2 days. So we have to start with week 5. One session has been done for week 5. Today we'll just go through, if you have a doubt, so just solve the question that is there, the activity or the practice. Even when is the deadline for the assignment submission?
Sir, for week 5, it is 15th July, and for week 6, it's 17th.
Okay, yeah. So you'll have to start. How many of you have started watching the lectures? How many of you have seen the lectures for week 5? I guess there are only 4 lectures, and those are pretty not that difficult. So that won't take much time. Maybe 2-3 hours. If you'll just invest 2 hours, you'll be done with the week 5 concepts, and then you can try it out. So how many of you have went through the content of week 5?
Sir, I haven't for the contents of week 5.
Okay. So yeah, so you can just go and I guess yesterday there was a session where the instructor has done the summary for week 5. Okay. Yeah. So whatever the doubt that you have, maybe we can start solving the activity questions.
Sir, we have doubts and activity questions.
Yeah, I'll just share my screen and then we'll try to solve all those questions in this.
Okay, sir. Thank you.
Screen. Yeah, my screen is visible, right?
Yes, sir.
Okay.
Doubt in activity 5.2.
I'll start with the very first questions. Just give me 1 minute.
Okay.
Yeah. So we'll start with, so this is week 5. So we'll start with 5.1. Okay, so 5.1, if you have any doubt, you can just ask me, or I'll just go through each question. Okay, so the first question basically is pretty simple, right? It's just saying that a student wishes to take either a statistic course or a mathematical course, but not both. Okay, and there are 2 statistical course, S1, S2 is the 2 stats course, and they have given 4 maths course, M1, M2, M3, M4. Okay, and then it is just asking that then the number of ways the student can choose the course. What do you think? What should be the answer? 2 plus 4, right? Either you can choose stats 1 or stats 2 or M1, M2, M3, M4, right? So that will be a one, like if he or she is using this is pretty simple. It was just asking the number of ways the student can choose the course. I guess this is simple. So now the second question is saying that this is also simple. They're saying that there are 13 flight from Delhi. So this is Delhi to Bangalore, and then from Bangalore to Chennai. So how many flights are there? Altogether, some 13 flights are there. 13 flights, and then from Bangalore to Chennai, there is some 6 flights. So what do you think? How many choices does you have to if you want to travel from Delhi to Chennai? How many ways you can travel? So for each flight, you'll be having 6 flights from Bangalore to Chennai, right? So if you have a 13 flight from Delhi to Bangalore, it will be basically 13 into 6, correct? 78, I guess. Is it right?
Yes, sir.
Yes. So that, yeah. So the third question is saying that if you have four certs and then five and a sweater, okay, for the school trip or whatever, and then you have to choose a shirt and a pant for each outfit and decide whether to wear the sweater, then find the number of possible outfit. Okay, so for you already know that if this is shirt 1, S2, S3, S4, right, and this is 5 pant, basically P1, P2, P3, P4 and P5, and then you have sweater S. Okay, so basically, you can choose one cert S1 and then P1. Similarly, you can choose S1 and P2. So for each cert, you'll have five different collection, like five and you can choose out, right? So each cert will be having a five options to choose out. And similarly, either it's saying that he needs to choose a cert and a band for each one, decide whether to wear. So what do you think? What should be the answer? Do you think 4 into 5 into 1 should be the answer, or what should be the answer?
So first we 4 into 5, then we have a sweater for every 20.
Correct. Yeah, correct. So whether he or she wants to wear the sweater, that is a one combination, and the other combination, similarly, if he wants to wear the sweater, and if he doesn't wants to wear the sweater, then also it have 4 into 5. So basically, we'll be having 20 plus 20. Correct. So one combination S1 P1 without sweater, and then S1 P1 with sweater. Correct. So you can just
Yes.
think of as, yeah, S0 and S1. So this is without sweater and this is with sweater. So all the combination, the one combination can be S1 P1 and then S0. Then the other can be S1 P1 and S1. Correct. This is with sweater and this is without sweater. So I guess this is simple. I guess there should not be any doubt in this. Then the fourth one and the final one for this first lecture is, in how many ways can a number be chosen from 1 to 20 such that is a multiple of 2 or 3? This, so you can directly count it out, right? Okay.
Yes, sir.
Yeah.
So, but what if we have a large count and we have to see the numbers in between?
Yeah. So then you have to choose, like, it's not that difficult, but yeah, if it is a very big number, then it will be a hurdle, because you can't use any method in this because you have to count it out, I guess. Yeah.
Okay, sir.
Yeah. There can be some tricks you can use it, but yeah, that depends on the question. If you have the question, then we can discuss. Are you able to see my screen now? Like, is it visible, right? The screen is visible to you.
No,
No,
sir.
sir.
So from the starting, it was visible or not?
It was visible till now, but not now.
No. Yeah. So now
Now it
the
is.
5 point. Okay, thank you. So 5.2 now. First question. It's just asking that how many ways you can arrange the alphabet of English language if you were to form all the words that are the 4 alphabets. Okay, so how do you do that? How do you do this type of questions? Permutation basically you use, right? When do you use the permutation? Can somebody tell me when do you use permutation?
Sir, when we have to choose and then arrange.
Correct. So basically you choose it out and then arrange. So basically the permutation is basically arranging the words. So you just choose it out. So from 26 alphabet you have to choose out 4, okay, and then arrange it. So basically 26 P4. Sorry, what's the question? No, I guess there's something else is saying, right? Okay, let me check it. So in how many ways can you arrange the alphabet of an English language if you have to form all the words that has 4 alphabets in them?
Yes, sir. In 4 places we have to arrange the alphabets. 26.
Okay. Yeah. Got it.
Yes.
So it's just saying that, okay, 4 alphabets are there. Okay, got it. Then it should be 26 P. Yeah, 4. It was correct, right? So whatever we have said is correct, I guess. So it will be what? 26 factorial upon 22 factorial. I guess the answer should be this one.
Yes, sir.
So this is saying, so whenever you have to choose out first and then arrange it, you have to use the permutation way. Okay, or you can use the basic method also, even though the basic method will work like if you have been given so 26 into 25 into 20, so that method also work. So if somebody is getting confused when to use permutation and combination will be taught in the next week. But if you're getting confused, you can just go with the basic approach also without just using these formulas and all. So you can do that also, like if correct. So with the basic approach also, you'll get the same answer. Like for this case, you can have for the first letter, you can have all the 26 letters. Similarly, 25 here, 24 here, and 23 here. Correct? This both are same, right? It's not
Right.
it? Yeah. So both are same basically. Similarly, for the second case, second question, is 2 factorial upon n minus 1 factorial. What do you think? What should be the answer? You already know that if you have to write this n minus 2, so you can write it like this, right? Into n minus 2 factorial into n minus 2 factorial. So this will get cut down. So you'll be left with 1 upon n minus 1. Correct?
Yes, sir.
Yes, sir.
Similarly, the next question is also simple. 10 factorial upon you have 3 factorial to 5 factorial. This is like just the calculation. So you can do it out. Fourth question. So yeah, which question you were asking? Somebody is asking from 5.2, right? I guess which one you were asking?
Yes,
Fourth
I
one
was
or which
asking
one?
second. I was asking the second one. Now it is clear, sir.
Okay, it's clear, right? So now the fourth one, if you just read it out, the fourth one, suppose you have a 6 ball, and then each ball is marked. Okay, so B1 to B6, and then what? You also have 6 slot that you can. Okay, this is simple, right? 6 ball, 6 slot. So how many different ways? It's just the 6 factorial only, correct?
Yes, sir.
So if you have slot 1, 2, 3, 4, you can just do it out 6 into 5 into 4 into 3. So either way you can do it, or it's like 6 P6, right? That is also the same. Is it clear to everyone? All the questions?
Yes, sir.
Let's move to 5.3 now. Okay. So 5.3, what are the first question? In how many ways can a test paper of 6 questions be attempted? Each questions being a true or false. Okay. How many ways can a test paper of 6 questions? So you'll have basically Q1, Q2, Q3, Q4, Q5, and Q6. And then how many ways? Okay. You have to attempt the paper, and then you have options true and false. True and false. TF, right? Similarly, TF for all the options. Okay. So if you just think of no, so if the question is written in this way, in how many ways can the test paper of 6 questions be answered? What do you think? What should be the answer? If I'm just asking how many ways can a test paper of 6 questions can be answered? So somebody can answer Q1 as true, then the Q2 as true, so all true, and then this can be a one way to answer it. Okay, and if you have here it has been asked to attempt, how can you attempt the question? But somebody can do it like all the true and then the last one he will not attempt it. So that is also a different way, correct? Apart from this, are you able to understand this?
Yes, sir.
Yes, sir. Yes, sir.
So that
attempt
means
the
we
question.
have 3 ways.
Yeah, correct. So the third one is to not attempt it. So this is like for if you are attempting, then you'll mark it true or false. If you are not attempting, you'll not be marking anything. So basically, you have 3 ways to attempt the questions. Okay, and if you have a 3 ways to attempt the questions, so what should be the answer now? I guess 3 ways for each questions, right? So we'll be having 3 to the power 6, I guess. 9Q. Is this clear?
Yes, sir.
So the next question is, the professor is creating an exam of 11 questions. So here also there is basically Q1 till Q11 from a test bank of 15 questions. So he's just choosing out 11 questions from 15. So this is also simple, right? So what will be the answer if you have to choose out 11 out of 15 and then arrange it? So it will be basically permutation. You can use it directly, right? Is it clear to everyone? So what should be the answer for this case? 15p. What should be the answer? 15p. If you choose out 11,
15p.
11, correct? This
So in the
basically what
question,
15.
is it asked to arrange the questions also?
It's asking na, in how many ways can he select and arrange the questions.
Okay, sir. Okay.
If it was just asking to select it, then you can directly use a combination. But here it is asking to arrange also. So first choose and then arrange it. Is it clear?
Yes, sir.
You can use it like the permutation also, but even though it will be dot. So and then you'll how many? So you can factorial. So same as 15p 11. In how many ways can a 4 identical ring can be won in a? So this is also same, right? 5p4. Correct. All these questions are pretty simple. Yeah. So I guess. Okay. Now what about this question? Can you solve it out? This is the question. Just asking in how many ways 5 distinct books can be arranged in 2 bookshelves. What do you think? What should be? How will you solve this question?
So we have 2 shelves and we have to keep 5 books on either of one shell and one shell empty, then 1 book in one shell and 4 books in one shell.
20.
20.
In how many ways 5 distinct books can be arranged in 2 bookshelves? So basically you have 2 bookshelves. Okay, I'll just 20 is not the correct answer. So you can try it out again. Like
720s.
10, sir.
No, 10 is also not correct. 720, I guess 720 is correct.
Yes, sir.
Okay, so there are some that basically you have 2 bookshelves. So you can just think of as this is bookshelf 1, B1 or B2. This is B1. Okay. So now it's just asking how many ways 5 distinct. So basically you have 5 distinct book B1, B2, B3, B4, and B5. Okay, so the first case is all the 5 books just went to this B1 itself. So if all the book went to B1 itself, so and then you have all the 5 books, and if you have to arrange those all 5 books, what can be the value? In how many ways you can arrange 5 books? So basically you have 5 slots. So in
5
book,
factorial ways.
5 factorial ways. Correct. So here it will be 0 because if you are just taking all the 5 books in B1 itself, so there is no books for the B2. Okay. So it's just asking how many ways 5 distinct books can be arranged in the 2 bookshelves. Okay. So this is the 5 factorial ways you can arrange it in book B1 and you don't have anything in the B2. So basically you'll be having altogether 5 factorial. Okay. Now the second case, what can be the second case?
So we can keep 4 books here in shelf 1 and then 1 book in the shelf 2.
Correct. So 4 book you can just put it here and 1 here. So to arrange 4 books, how many?
4 factorial.
4 factorial.
Correct. Yeah. So basically, what are we doing? Basically, we are just choosing out k books. You can just think of as a in one of the book cells. So basically, we have 5 books. Correct. Altogether 5 books. So we are just choosing out of 5, 5C, 5CK is coming. So we are just choosing out 5CK, and out of that, so first we are choosing out K books out of 5, and out of that K, let's for example, is going to B1, book self 1. The remaining n minus K factorial for B2, correct? And this you have to sum it out. Did you get the idea? So what we are doing basically, out of this 5, you just think of as K went to B1. And if K went to B1, we have to arrange that K books, right? And how can you arrange K books? K factorial ways. Similarly, what are the left? N minus K is left for B2. So how many ways are there? N minus K ways, N minus K factorial ways to arrange those books in B2. Did you get the idea or not? Should I repeat it?
Can you repeat it? Can you repeat this, please?
Okay, one
So
second.
please repeat it.
Okay.
But I have a doubt here. When we actually can choose 2 different shelves, so we can actually make a combination of 3 plus 2, 2 plus 3, whatever it is, and so on. So in every case, either of the shelf will have factorial of the number, right? That's how it looks.
No, so basically, it's so the question is saying that you can just think of as a two room itself. Like you have to put the books in 2 different rooms itself. Okay. So if you're just so out of this 5 books, if you have 2 different books where you can just skip it. Okay. And in that room also, you have some places where you can like arranging the book is like so if you're just putting B1 upon B2, so that's a different way. Okay.
Yeah.
So what we are going to do here is, first of all, we were having 5 books. So out of that, first we have to think of how many books went to the B1. So you can just think of as 2 rooms. So room 1 and room 2. So how many books went to room 1? In that room itself, how many different ways are there so that we can keep those books in room 1 itself. Okay. So basically you can just think of as room 1 and room 2. And 5 different books are there. And you have to just keep those 5 books. Okay. And so this 5 books, out of this 5 books, some books will go to room 1 and some will go to room 2. Correct? So let's, for example, 5 went to, it's not combination basically. Okay, I'll just write it out. What are the conditions that can be there? So out of this 5, let's for example, all the 5 in first case went to room 1 itself. And there is nothing in the room 2. So if all the 5 went to room 1, you'll be having 5 factorial ways. Correct?
Yes.
Correct? Yeah. Similarly, the second case can be, out of this 5, we are choosing out 4 in the room 1. The remaining 1 will go to room 2. Okay. So whatever I was writing in the earlier case, that is totally correct. So you just have to do sum it out. So 5 factorial ways. K books went here and n minus K will go here. So k factorial ways will be for the arrangement of this and n minus k factorial, and there is a, you have to choose out also. So 5 ck, for choosing 5 out of 5, you are choosing some k books, right? Because if you are just choosing the first case b1, in this b1 the first one book came, and that one book was b1, okay, and the all 4 went to b, the second room, correct? b2, b3, b4 and b5 went to the second room. Okay, these are different conditions, as if, let's for example, in only one book went to room 1, but that was b2, so the remaining 4 is what? b1, b3, b4 and b5. That's a different case. Are you getting me or not? Are you getting my point or
Yes,
not?
sir.
Yeah, so basically out of this 5 books, first of all you have to choose some books, okay, some n number of books. So out of 5, some will go to b room 1, some will go to room 2, okay, and whatever went to room 1, that you have to arrange. So basically whatever the number, let's put this k went to room 1, so k factorial will be the ways to arrange those books, okay, correct? Similarly n minus k factorial will be the ways to, in the room 2, to arrange those books in the room 2, okay. Similarly you will be having, and whatever the k that you are selecting, that k also, to choose k out of 5, there will be some ways, right? So if I already told you, let's for example k was 1, for example, okay, so if k is 1, so there can be 5 ways, like first, in first case b1 came here, b2 came here, and then b3, b4 and b5. So when b1 came here, so all the remaining 4 went there. Similarly b2 came here, then the remaining b2, all the 4 went here, okay. That's a different scenario, right? So basically you can directly do it out. You have to choose it out of 5, you have to choose k, correct? And then out of this, k factorial for room 1, and for room 2 n minus k factorial, okay, and then you have to sum it out. K will be from 0 to 1. I guess that should be the answer. Is it clear to everyone or not? So first you have to choose, okay, and whatever went to room 1, that you have to arrange. Whatever went to room 2, that you have to arrange, correct? So the first case would be k equals to 0. So k equals to 0 is 5c0, and then 0 factorial into n factorial. Similarly plus 5c1 1 factorial into whatever the number, 1 factorial, and then 4 factorial. Similarly you can add it all the values, you'll be getting the answer. Is this clear to you? Are you able to hear me or not?
Yes, sir.
Yes, sir.
Yes. I have done it in a different way though.
Okay.
6
How
into
did
5
you?
factorial.
6 into
5 factorial.
how did you do that?
So we have 6 ways of keeping the books, and with 5 factorial books.
Where it is said that there are 5, 6 different ways?
So one's keeping 0 book in shelf number 1, and then 5 books in shelf number 2, then 5 books in 1, and 4 books in 1, and 1 book in other. Like that, we have 6 ways.
Okay.
And we have 5 factorial books.
Yeah, I guess that is also correct way to do that. Yeah, that is also correct. Yeah.
Okay, so
But if
there's
some, yeah, that is also correct. But I just told you the basic. If you don't know anything, how can you approach this question? But that is also a correct way to do that. 6.
Can you repeat this again, this sigma, because I just joined.
So what I was saying is, I'll just give you my approach. How did I solve this? So the question was, how many ways can 5 distinct book can be arranged in 2 bookshelf or 2 room, different room? There are 2 different rooms, and then there are 5 books that you have to keep in 2 different rooms. How many ways you can arrange those books, okay, in 2 different rooms?
yes.
So I just thought of, out of this 5, there will be some books will go to room 1 and some books will go to room 2. Let's for example, k book went to room 1. If k book went to room 1, so there will be k factorial ways to arrange that in room 1, correct? Similarly, n minus k factorial ways to arrange those books in room 2, correct? So these are for the arrangement. So 5 books we have to arrange k and n minus k, like 5 minus k. This arrangement has done. Now you have to choose out also, right? Because room 1 will be, so k book is going. So which k book is going? So 5ck should be the ways in which we are choosing the books. So k has been chosen, and then out of that k factorial is to arrange that, and n minus k factorial to arrange in a different room, the second room. And then that k value can go from 0 to 5, so that you have to add it up, sum it up. Okay, or whatever C said, that is also a correct method. Okay, is this clear? You can just try it out this method and then check it what's the value you are getting, whether you are getting 720 or not.
Yes, sir.
I think so you should be getting that.
Yes, sir.
So now move to the next part, I guess. Here also find the, okay, so I'm just asking you, this is the word. Now you have to tell me the number of, find the number of rearrangement of the letter. Okay, so just give me the approach. How will you solve this question?
So we have total number of letters as 11.
Okay.
So 11 factorial divided by the number of repeating words. That is G, that happens twice, M, that happens twice, and R, that happens twice. So 11 factorial divided by 2 factorial, 2 factorial, and 2 factorial.
N is happening only once, right?
Yes, sir. Other
M is twice. G is twice. I guess there should be 11 factorial upon 2 into 2 factorial, correct?
No, sir.
And also
R is also there.
R is again twice.
Okay, R is also twice. So 2 factorial. Okay, yeah, so this should be the correct answer. This is clear, right? To everyone? The basic formula, right? So
Yes, sir.
basically you have to arrange it, and then if you have a repetition of word, then you have to divide it, because that will be counted. That, like, if you are just not dividing it, that means that is been counted out again and again. So that's why we are just dividing out, so that you have to find a unique number of ways, correct? So that's why to find the unique number of ways, you'll have to divide with the factorial. So whatever the repetition is there, repetition of word, because if it was M1 and M2, you would not have divided. As it is MM, because whether you write it this M1, M2, let's for example, I'm just writing it out, or M2, M1. As both are M only, so both are same. So that's why you'll have to divide it. So as you can see that if M1, M2 was two different words, then you would have got two different ways to arrange this M1, M2. But you already know that both M are same, so you'll have to divide with 2 factorial, so that the number of ways will be 1.
Yes, sir.
Yeah. All this formula you should be knowing. Even though you're not knowing the formula, without formula also you can just solve this question, this type of question. Yeah. So the next problem that we have is, in how many ways can a letter Caesars be arranged so that all the S are together? Okay, so this is also a good question. So basically the word SEI, Caesars, and you have to find how many ways can the letters of the word Caesars be arranged. So arrangement you have to calculate so that all S are together. Yeah, so what do you think? What should be the,
So we should take a box and enclose all the S together first of all.
okay, so all the S, so 1, 2, 3, 4, so all the S you're just putting as a one value, one
block,
letter.
yes, sir. And then we should consider it as a single block. So the total number of letters will be 1.
Okay, yeah,
Will be 5.
correct. So basically you're just taking all these 4 as a one letter.
Yes, sir.
Consider it as a one letter. The remaining words are what? SCI. So CI and then what is there? OR. OR. So you can just think of this as a one letter and then this all different. So all now you have how many distinct letters? 5, right? So this is
Five.
one. So 5 factorial should be the number of ways in which you can arrange this one, right? So either you can put it this here. So 5 gaps are there. You can directly put this all 4 here or here or here or here. And similarly CS. So basically you have 5 factorial ways. Correct? So 5
Sir,
factorial is, yeah.
5 factorial into 4 factorial, because we have one group as SSSS and these are can be combined again in 4 factorial ways.
The S
No,
is not
no.
distinct.
This S is, if it was S1, S2, S3, S4, then you would have written 4 factorial into whatever 5 factorial. Okay.
Okay, sir. Okay.
But all the S are same. So either you write 1, 2, 3, 4, or you write S2, S1, S3, S4. This is same, right? Both are same because S is same. Are you getting me?
Yes, sir, right.
Yeah. So that's why. If it was different word, like it was written that all the words are different, and then you have to write this 4 digits. So S1, S2, S3, S4, always together. Or you write it as these are all distinct. So 8 distinct word, and this CIOR should be always together. These 4 words should always be together. Okay. And these 4 are different. Then you would have written like this 5 factorial, because this 1 plus 4, this is 5 factorial. And inside this also you can arrange this CIOR as a 4 factorial different way. Then the answer would have been 5 factorial into 4 factorial. Clear? Yeah. I hope this is clear. Okay. So the next problem is, what's the next problem? So this is the third one. Am I audible?
Yes.
Okay.
Yes, sir, you're audible.
Yeah. So the next problem is 7 people are going to sit on a round table. How many ways can? Okay, this is simple, right? So 7 people are there. You'll just fix 1 people. So remaining 7 people are there, right? So just fix it out 1 people. So you'll be left with 6 other people, right? So you'll be having 6 factorial ways in which, so if you're just fixing for a round table or any like in a round table, somebody has to sit or arrange in a round table, you just fix one thing with respect to this itself, you'll just put it out, right? So if just with respect to any particular seat, okay, this is S1 seat, and altogether you are having 7 seats, right? So with respect to S1 seat, you can just arrange this 6 factorial different ways. So that's why the answer should be 6 factorial. Is this clear?
Yes, sir.
And if it has
Yes,
been
sir.
told that whether you go from clockwise or anti-clockwise, if both were same, then you would have divided by 2, right? Because you already know that even though you are fixing, you are calculating with respect to S1, but if you are going in this way or this way, both are same, right? Then you have to divide with 2 also, correct? Because this anti-clockwise and clockwise are same, so that's why the arrangement from clockwise and anti-clockwise are same. That's why you have to divide it with 2 to get the unique number of arrangement. Is this clear to everyone?
Yes, sir.
Yeah. So now you have been asked what is to find the number of ways in which 8 beads can be arranged in the necklace. What should be the answer? 8 beads are there.
7 factorial by 2.
7 factorial by 2. Why are you dividing with 2? Because in a necklace, either you go from this side or that side. Both are same, right? Correct? Because all
Yes,
the
sir.
8 beads are identical. So you'll have to divide with this way.
Sir, I didn't get this.
Sir, I have confusion in this question. Please repeat.
So in this question, see, what has been asked is, you are just making a necklace with some 8 beads, okay? Maybe, okay, 8 beads, you're just using it out to make a necklace, right? You have to arrange that with the 8 beads, correct?
Okay, yeah.
Yeah. So in the necklace, you already know that how does the necklace looks like. It is basically from you go in anti-clockwise or the clockwise direction. Both will be same, correct?
I I don't know why to say that it's the same in clockwise and anti-clockwise. If the beads are the same, then why are we even permuting it? It's always the same. If the beads are of the same color and we can't differentiate them, then why are we permuting it? There is only one way to look at it.
Okay, I guess the beads would be different, because if the beads are same, okay, if the beads should be same, then there won't be any, like, I guess there will be only one way to do that. But
Yes.
because if the beads are identical, then you can't even know like which beads you are putting where. So there will be only one way, right? So beads should be different, I guess. That there should be 8 distinct beads. Okay, maybe the shape or size, something will be different, right? So if you have a necklace, so maybe there will be
Colors.
some different ways. Yeah, colors will be different, but identical. It's why they are dividing it, because I guess because of that condition only. Because either you go from left side or right side, you can just think of as this way. Like if you have a something like that, and then here it is a triangle and here it is a circle. Okay, so either you go from this side or that side. Okay, let's for example, you are having only this 2 beads were there, right? If it is a triangular, this is a circular. Either you put it here or put it here. In both the ways, it's same, right? Whether you go by clockwise, this is clockwise, or anti-clockwise, both are same, right? So either you write it as triangle, circle, or you're writing it as a what? So both are same, I guess. Either you go from this way or you go from this way.
But sir, if you write 2 circles, then then 2 of the beads are identical, then, right?
No. This is just an example I'm saying, but the beads should be different.
Then why is the clockwise and anti-clockwise same?
See, I'm just telling you. Because see, if you are just, I was just giving you this example. Even though if you'll just flip it out, I guess you'll be getting the same reflection for a necklace case.
Okay, and flip it out as in?
Yeah, so if you are just necklace, whatever the necklace that you have, if you are flipping over, it will not result in a unique arrangement. It will be same arrangement.
Yes, but it will just look inverted.
Yeah, correct. So that's why we are dividing 2. Okay. Yeah.
So so the next
so
time
whenever there is a so whenever you have to make some necklace or those type of cases where it has been mentioned that it's like a clockwise and anti-clockwise, both are same. So only this type of cases will work on here only, like necklace or maybe what do you call that? This flower, different flowers are there. So those type of cases you are making some like with the help of some flowers you make, right? So those there also the clockwise and anti-clockwise both will be same. So in those cases,
any 3D objects which we can flip in real time.
correct. So in those cases you'll have to divide it. Otherwise, in all the other cases where you are just sitting or the arranging the books in a circular ways, all those cases will be having the clock and the anti-clockwise will be different.
Sir, how we get to know that the beats are different and they are not same?
Yeah, it's not written here. So
yeah, so I think I was told to assume every time that is not specified that they are the same, we have to assume that they are different.
Yeah, you have to assume it. Otherwise, I don't think so. There will be any other ways to arrange it, because if all the same, so let's for example, I'm just giving you, you're just buying an apple, right? So 5 apples are there, all are very identical to each other. Okay, if you have to just pick it out, in how many ways you can pick one apple? So basically, it's not 5; it's basically one only, right?
Yes, sir.
Because you have A, and you have been asked to just choose one. It's not that you're just choosing A1, A2, A3, A4, A5. Even though you're choosing this apple, this is like identical. So it's just a one way to choose it. So if the beads are identical, I don't think so the answer would be correct. But even though I'll just check it out, but I don't think so. It's a identical beads. That's for sure.
Okay,
Okay.
sir.
Yeah. The next part is, and this is a simple one. So n plus 1 p2 equals to 4 times n p1. Here you have to calculate the n, and this type of question generally comes in the exam also. So just you should be knowing how to write the permutation and combination. That's it. And if you'll just solve it out, you'll be getting the correct answer. Okay, let's move to the practice questions. So I'll just go to the practice. So activity questions, everything is done right. Anyone is having any problem in the practice question, you can just ask me out.
Sir, do we have combination in this week?
Combination you don't have to. Next week we'll be dealing with the combination.
But sir, some of the questions require combinations to solve.
Yeah, because see what happens now, earlier this both the weeks was composed in only one book. So both weeks topics were taught in one book, 1 week itself. But later it was bifurcated to 2 weeks.
Oh,
so that
they didn't update the question.
Yeah. So the sum of the question, because permutation and combination, you can't just separate it out. Some questions can be there. See, even though without combination you can solve most of the questions, or without using the permutation also, the formula.
Yeah.
It's just
by law.
just by the
Counting.
normal multiplicity and addition rule, you can just solve all the questions with the factorial rule. But yeah, sometimes the same case, right? One question I was solving, and here I was using the combination. But even though this can be solved without the combination. Okay, so practice assignments, just solve it out. We'll just see that. And whoever has not seen the content, please go through that, because we'll be having session again. So you can just come up with all your doubts in that session. I guess next, I guess Thursday there's a session, or Friday, I guess there's a session. So practice assignment. So which all question you have a doubt? Practice assignment, or I should go from starting to end? Can you hear me? Am I audible?
Yes, sir. You are audible.
Okay. So I'll just start from the first question. I guess if we haven't solved the practice assignment. So basically, the first question saying that there are 10 multiple choice questions. Okay. So there are 10 questions, and out of that 10 question, 5 questions. So 5 is having a 4 choices. So 4 options are there, and 5 for the 5 questions, you will be having 5 options. Now you will have to tell me how many sequences of answers are possible. So here you don't have to say me the number of ways you can attempt the question. You just have to tell me how many sequences of answers are possible. And these are all MCQ questions, not MSQ. Can somebody tell me?
Sir, I guess
Basically
20 plus 25.
20 plus 25. No. So how come 20? Like, how did you get 20? So 10 questions are there. So Q1, Q2 till Q10. Starting 5 questions have 4 options each. And last 5 questions you have 5 options each. And what can be the sequence of answers? So like one sequence can be somebody is using A for all the 4, and then let's, for example, he just using A all the 10 questions. That can be a one way to answer the questions, right? Okay. So let's for example, so for Q1, Q2, Q3, Q4, Q5, how many ways you can just answer this Q1?
4.
4 ways, right? Because you can just choose it out A, B, C, D, correct? So 4 ways. How many ways you can answer Q2?
4
4.
ways.
4 ways, right? Similarly, Q3, Q4, Q5, all 5 you can just choose it out in 4 ways, right? So 4 to the power 5.
5.
What about Q6, Q7, Q8, Q9, and Q10?
5 to the power 5.
To the power 5. And all the 10 questions, what you don't have to add it out here. It's not saying something like or something. It's just that all 10 questions you have to tell me the sequence, right? So it is like 4 to the 5 into 5 to the 5. Okay, this would be the answer. Is it clear to everyone or not? Should I repeat it?
Yes, sir.
It's clear, right?
Yes, sir.
Okay. Let's move next question. Let's move to the next question. It's just saying that how many numbers. So this you have to tell me. I guess is a very big number. I'll just make it small. How many numbers between 0 to 100? Okay. And you just have to use it. Can be formed. How many numbers? Between 1 to 100, or maybe let's make it 1000, can be formed using 0, 1, 2, and repetition is allowed. Okay, so this is the question: how many numbers between 0 to 1000 can be formed using 0, 1, 2? Tell me your approach. How will
So repetitions are allowed, sir.
yeah, repetitions are allowed.
So for the hundreds position, we have only two choice, and for the remaining two position, we have three choices each. So it will be 2 into 3 square.
2 into 3 square. What about others?
Sir, I haven't practiced the assignment questions till now.
Okay. So can you try it out now? Like how many numbers between 0 to 1000 can be formed using 0, 1, 2? So this is between. So basically, you don't have to choose it out 1000 and 0. So you have to exclude 1000 and 0. So basically, it's asking from 1 to 999.
Hello, sir.
Yeah.
Sir, from 0 to 1000, we can make 3 raised to 3 and excluding 0 minus 1.
So 3 to the 3 minus 1. Okay. How did you solve this? I guess this is correct. Yeah.
Sir, there are three position, 100, tens and unit. Therefore, I arrange number 3 into 3 into 3.
Okay.
And I can't repeat 0 at all places.
Because
Therefore,
that
I
will be 0.
minus. Therefore, I minus 1.
Yeah, correct. Because that will include 0. So you have to exclude 0. So that's why you're just subtracting 1. So just exclude the 0. Yeah, that is a correct.
If we just suppose put 0 before any number comes, does that only mean it becomes a two-digit number or a one-digit number?
Can you give me an example?
Like suppose 009.
That's a one-digit number.
All right, suppose 089. It does basically becomes a two-digit number, right?
But they are not saying that the number should be of 3-digit or 2-digit. It's just saying that how many numbers you can make it from 0 to 1000. It's not saying
But
how many.
if it is saying 0 to 1000, is it including 0?
0 to 1000, I mean between 0 to 1000. It's not including 0 and not including 1000. So even though if you are just choosing out, so here if you are just choosing 0 here also you are just choosing 0. Here you should not be choosing 0. Here you can choose any of the three. right? For example, yeah, 1 you are choosing. So that is also one number that is lying from 1 to 999, correct? So for all these three positions, you can choose it out, all the three values. Okay. But only one
Alright.
exception is whenever you are choosing 000, you just have to exclude that value, 0. And other cases are fine. I guess this is clear to
Okay.
everyone.
Yes, sir. So the answer that I gave is basically for 3-digit number.
Oh, okay, okay, got it, got it. Okay, okay. So here they're not saying digits should be fixed. It's just saying that number should be between. Okay. So now let's. This is also a good question. So it's just saying that I'll just write it out. You have to try it out. That may take like you'll have to try to solve it out. Suppose that there is the number of score the number. So basically the run can be scored, and each ball or delivery is 1, 2, 3, 4, 5. So you already know that. So batsman can score from 1, 2, 3, 4, 5, 6 on each delivery. On each delivery. Now it has been said that told that a batsman is there. He played 3 delivery. So he basically played 3 balls. He 3 delivery. He played. Now it has been asked a batsman played 3 deliveries. Then find the number of possible outcomes such that he hits 2 runs of at least 1 delivery. Okay. So are you getting more points? So he just played 3 delivery, and you have to find the possible number of ways such that he hits 2 runs of at least 1 delivery. Okay, 1 delivery. So basically 3 delivery is playing. Okay, he can score anything from 0 to 6, like 1 to 6, but at least in 1 delivery, or let's for example at least one. That means 1. This is 1 delivery he scored 2 runs, 2 delivery he scored 3, and all the 3 delivery he scored 2 runs. Okay, so in one of the 3 delivery he scored 2 runs. Here these are the condition where out of 3 delivery he scored in 2 runs in 2 delivery, like basically 2 each, and again for all 3 he has scored 2 2 2. Okay, so now you have to tell me the number of ways he can do that. Okay, so what do you think? So if he is just hitting 2 runs of the 1 delivery, so out of this 3 he just choose it out the first delivery he scored 2 runs. What are the other cases? What is the value that can come here and here?
1, 3, 4, 5, 6.
Correct. So 1, 3, 4, 5, 6. So 5 values can come here, right? Similarly, here also 5 values can come here. Clear?
Yes, sir.
Or not?
Yes, sir.
Correct. Yeah. So okay. So okay, yeah. So this 5, he can score 5 runs on the second delivery, or he can score like not 5 runs basically. Basically 1, 3, 4, 5, or 6. Out of this 5, he can score 1 out of this, because he can't score 2, because you already know that we have just split it out into 3 conditions. The first condition is where he just scored double in 1 of the 3 delivery. Here out of the 3 delivery he scored double in 2 deliveries, and here all the 3 deliveries he scored 2 runs. So if he has scored 2 runs in the 1 delivery out of the 3, so I'm just taking out, so he just scored on the first delivery. He can score in the second also, he can score in the third also. So in the first, if he has scored 2 double, so the 25 ways are there, right, in which he just scored 2 runs in the first ball, and other 2 balls he would have scored 1, 3, 4, 5, 6, and similarly on the last delivery also he would have scored 1, 3, 4, 5, 6, right? So how many ways are there? Can you tell me?
75.
3
how
into
75?
25? How 75?
So 3 into 75. There are 3 ways to place 2.
3 ways to place 2. Okay, correct. So 3
multiplied by 25.
multiplied by 25. So you are getting 75 ways.
Yes, sir.
75 ways from here. The first
Yes, sir,
condition.
for this case.
Correct. Now for the second case, what can be the value?
3C2 into 5.
3C2 into 5.
Sir,
Correct.
can we solve this using the like logic that we are taking all the possible outcomes of the types of runs we can score of 3 balls, and we can then we subtract that by the number of ways by which we 2 runs are not scored in any of the balls. Can we do
That
that?
also, that also you can do. That also you can do.
All right.
Yeah, that is also a good method to solve, because you are just thinking of just
Because
scoring.
it's just since it's at least 1 ball, so you can like take off the cases where 2 runs are not scored.
Correct. So yeah, so that also it can be method. That can be also a good method to solve that.
Sir, in that case, shouldn't our answer be 3 raised to 3 minus 75, sir? So that negative case, the
It's actually
one
6 raised 3. It's 6 raised 3 by minus 5 raised 3.
didn't get your point. I mean, we have 3 places. So how did you
But
calculate that?
just like 6 into 6 into 6, 6 times.
Minus 75.
No, not minus 75. It's just 5 into 5
5
into
into 5 into 5 into 5, I guess.
like we are taking off the cases where.
Okay, right. Correct.
Yeah,
Got
that
it.
is also a good method. Yeah. So you're just putting out 6 into all the 6 conditions can be there, and then you are excluding this 2. So it will be
Yes,
216, I
sir.
guess.
So that is a
Two.
better way.
Yeah, that this is what 125. I guess you should be getting 91. You can just check it out whether we are getting 91 from here, because here we are not excluding anything. Here also, I guess nothing has been excluded. So here also, if here from here we are getting 75 ways. Whatever this case, 3C2. What is the 3C2? And then 3 into 5. This is basically 15. And this is the one way. So basically we are getting 75, 15 and 1. So 91 we are getting from here also.
Yes.
Yeah, so both are good method, but yeah, this is a better one. Correct. Okay. Let's move to the next part. So next part is, so next question is pretty simple, right? So the fourth question is just saying that suppose there are n1 door. So n1 is the number of doors that are available to enter. So basically there's a stadium. So there are some n1 gates, n1 gates are there, and there is some exit, n2 gates are to exit it. So what do you think, if somebody wants to enter the stadium and exit it, in how many ways can he enter or exit it? If we just
2 raised to n1 into 2 raised to n2.
no, if you there is a two.
Sorry, sir, my
entry
mistake,
room
sir. We will use only one way, sir. My mistake, sir.
Yeah. So
sir,
if
it
you
will
just
be n1 c1 multiplied by n2 c2.
n1 c1.
C1 multiplied by n2 c1.
So what is the c1?
So number of ways to choose one out of n1.
That okay. So even yeah.
I'm just taking one out of n1 and similarly one out of n2 and making a choice.
That is also a correct method. That is a correct. But yeah, that is correct. So you're just using first one, and then with the first, basically you have n2 method.
Yes, sir. Yes, sir.
N2 ways. Similarly, you have for second also you have n2. So basically you have n1 into n2 ways.
Yes, sir.
Correct?
Yes, sir.
So the next problem is, yeah, so what I'll try to, so please everyone just go through the lectures and try to finish this week 5 content as soon as possible, because again the week 6 will start, and then there's no point, like, because we have bifurcated week 5 and 6 because we just wanted to give you some more time for the week 5 and 6. Okay, so if you're just not watching and then again in the end one you'll be watching, then there's no point, like it's not going to help you. So it's better you just go and watch the content, practice the activity. Even though I've solved all the practice activity questions, practice also I'll be solving. So if whenever you'll be just going through, you'll be having doubt, you can just watch this lecture again. So wherever you'll be having a doubt in any of the questions. So now the fifth question is, Prakash is going to assemble a laptop. So he's just assembling a laptop by himself. He has a choice of chips from Intel. So chips is there. So he needs chips, right? Okay, and the chips can be from, so there's two companies that has been given to him. So Moto, and the other is Nvidia and Qualcomm also. The other thing that he needs to a hard drive. Okay, a hard drive he needs, and that also is of 4 brand has been given to him. And then memory he needs, and that is from 7 brand. Okay, and an accessory bundle from 10 local stores. So some 10 local stores is there. So now you have to, how many ways can Prakash order the parts? So this is simple, correct? So right. So let's, for example, with Intel you'll be having a particular hard drive. So with Intel you can have 4 hard drive companies, then 7 memory brand, and then 10. So basically 10 into 7 into 4 just for the Intel. Similarly for all the other 4 you'll be having 4 multiplication, right? So you'll be having this many number of ways that you can order or you can assemble the parts. Is it clear to everyone?
Yes, sir.
Yeah. So now the next question is, so the sixth question is, it's just saying that Rohit wants to, so I'm just writing this question, you have to write out. So you have basically, you have to create a 4-digit password. Create a 4-digit password. Okay, and this, out of this 4 digit, the first 2 digit, 1 2 3 4, the first 2 digit are alphabetical, and the remaining 2 digits are numeric. Okay, just give me 1 second. Somebody is there.
Sir, is repetition allowed?
Just give me one minute. Just give me 1 minute.
Repetition is allowed for alphabetical but not for numeric.
Yeah. So basically, you have to create a password of 4 digits, and then the first 2
Excuse
is
me, sir.
alphabet. Yeah. Go ahead.
Sir, I have a general another type of question. Can you solve it in next? I will type it in chat box.
Yeah. You can just type it out.
Thank you, sir.
Yeah. Okay. So
Sir,
here
it
the
would,
question. Yeah.
the answer would be, as I have solved, 26 into 26 as the repetition is allowed, and 10 into 9 for the numeric part, as there is no repetition in the numeric part.
Okay. So just I'll just repeat this question. So you have to basically create a 4-digit password, and in that password the first 2 digit is alphabetical, the later one is numeric. Here it is repetition is allowed. Here is not allowed, but there is a thing that has been given here is both the uppercase and lowercase alphabetical can be used. Okay, so if you are using A and if you are using A, this is a 2 different word you can just think of. Okay, so uppercase and lowercase both are different here. That has been given in the question. Now tell me what can be the number of ways that you can create this password.
It will be 26 factorial small 20 plus 26
52
factorial
into 52
Yeah, that will be 52, right? Because
to
you can just
52 in, yes, sir.
Both are
Because
different.
yeah, both are different because 26 alphabets in the lower case and 26 alphabet in the upper case. So you'll be having 52 letters, correct? Alphabetically.
Yes.
Similarly, 52 for the second case because repetition is allowed. Now you have 10 because only all the 10
10.
you can use it, and here you can use 9
9.
words.
Yes, sir.
Correct?
Yes, sir. Yes, sir.
Yeah. So that's why you should be having 52 into 52 and 10 into 9. Is this clear to everyone? What?
It's clear, sir.
Yeah, okay.
But here I have a doubt here because for the first for the alphabets you are saying 52 into 52, whereas in numeric you give it's 10 into 9 or just 10 comma 9.
10 into 9.
10 into.
Because here repetition is not allowed. Here repetition is allowed.
I just so that will be 52 into 52 into 10 into 9.
Correct. Because there won't be addition because you have making a 4-digit number. You can't make it 2-digit and 2-digit separate. It's the AND condition, AND, right? Because you have to make a 4-digit number, 4-digit password. Okay, so that's why the AND should be used.
Okay, suppose this is a kind of a odd thing. Suppose if we make it as a what do you call the special characters also, what will be the case here?
Special character means what?
I mean that normally we use art on all the symbols that are normally for the alphabet when we use for the password number, right? The combination. Is there a way to kind of the way we actually jotted down the number of 52 for alphabets and 9 for numeric? For the special character or the special thing, we have any number for that?
That I am not aware of how many special character numbers are there in the on the phone or wherever we use
I
it.
just want to clarify, nothing complex.
Okay, no, okay. Okay, so the next problem.
Sir?
Yeah.
Sir, I have written the question in the chat box. Can you solve it?
Yeah. Where is that? Where is in the chat box? Huh?
Yes.
Okay. Can you see my screen, or is it visible or not visible?
No, sir.
No, sir.
Just copy your question. Okay, so the question says the Raman. Okay. Okay, yeah. This visible?
Yes, sir.
Yes, sir.
Yeah, so you're saying, let me copy your question. Yeah, can you speak it out? I'll have to again go and read the question. Yeah, whoever sent the question, can you speak it out? I'll just write it here.
Yeah, sure, sir. Raman has N trophies.
Okay, and trophies
that he wishes to place in his cupboard.
Okay, he wishes to. Okay.
Which has space only for 2 trophies.
Okay, got it.
If the number of trophies is increased by 3, then the number of possible ways to arrange the trophies in the cupboard becomes 5 times the number of ways to arrange n trophies. How many trophies does Raman had initially?
Okay, so this is what basically if the number of ways in which okay, 2 trophies are there, right? So what should be the n into n minus 1, correct?
Sir, can we directly write n plus 3 p2 is equal to 5 multiplied by n p2?
That also you can write it. Or see, n plus 3 trophies are there, right? Now how many ways are there for n plus 3 times what? N plus 2, correct?
Sir, how these values came, I am unable to understand.
So if you have a 5 trophies that you have to put, okay,
Sir,
and you have
it is
only 2.
graded assignment question.
Oh, okay. So
Not allowed.
yeah, it's not. Yeah. So, but I'll just give you an idea. Okay. So basically, I'll just you can just think of in that way. If you
Yes,
have a
sir, I
5
want the, I don't want the answer. Actually, I want the how to solve it, solve this type of questions. I want to know that. I don't want the answer.
Okay. See, basically, what happens here? You have told me the number of the trophies. So basically, if you have n trophies, right? So if you have just 5 trophy and you have to put in 2 places, you have just have 2 places. How many ways you can put? Either you can put all the 5, right? All the 5 you can put it here. All the 5 they put it here in the first case, right? You can put the trophy. Let's for example T1, T2, T3, T4, and T5, right? So if you're just putting, if you have to arrange this, right? How do you arrange? Basically, you write it like this. You just choose it out 2 out of 5. You choose 2 because you just have 2 places. Okay, and then you arrange 2. How do you arrange? Like it's like simple, right? Okay, if you're not able to get it here, there's 2 places that you can put it. If you're just putting, so let's for example, if you want to put one trophy, in how many ways you can put it one trophy from here? What do you think? What should be the answer here? You just have to put one trophy here. And how many ways you can put?
5 into
5.
4.
5. Okay, and if you, let's for example, you just put it here some trophy, so you will be putting some here, right? Because you have 5 options to put. You can put T1, T2, T3, T4, T5, all the 5 you can put it here. And if you have kept already T1 here, what are the left remaining values? If you have just kept T1 here, you don't have T1 now. You just have 4 other trophy, right? That you can put it here. So that's why you have left with 4 other trophy, correct?
Okay, sir.
Got it, right? So similarly, if you have
Yes.
n trophies, you'll be left with n into n minus 1. And if you have n plus 3, you'll be left with n plus 3 and n plus 2. And whatever the other condition that has been given, just equate it to that and you'll be getting the answer. Okay?
Yes, sir, I got that.
Yeah.
Thank you, sir.
Okay. So let's move to the next part and the next question. So we'll just deal till 10th question. More 4 questions that will give you more clarity about how do you solve. I guess the question number 8, 7, you don't have to use any, you just have to count it out. I guess this is a difficult problem. We'll try to sort it out. You have to find the ratio of a number of 3 digits. So basically, you have to create a number of 3 digits, or number of 3 digits. Okay, and all the numbers all are even. Okay, and whose digits either increases or decreases from left to right. Okay, so basically you have to create a 3-digit number, and whenever you're putting the values, that should increase or decrease. Okay, there can't be any values that, there can't be a value something like 8, 4 and 6. This can't be possible because it should be something like 864 or 468, something like that. Whether it should be increasing or the decrease, like it's a decreasing or an increasing trend. Okay, whenever you are creating a 3-digit number. Is it clear to everyone? So the number that you have to create is the number of 3 digits whose digits either increases or decreases from left to right. Okay, clear?
Yes,
Either
sir.
then you have to get the number of 3 digits, number of 3 digits, and here all the values, all the digits are even, are odd, and whose digits either increase or decrease from right to left. So here it is left to right. So here it is left to right, it should be increasing or decreasing. Here it is right to left, it should be increasing or decreasing. Okay, and after getting both the numbers, you have to just take the ratio of that. What do you think? What should be the value? If you are just taking the even numbers, what are the numbers that you can choose out?
So it will be
even
246 and 135. 246 or 532 to 531.
Correct. Okay, so you have to choose a number in an increasing trend. Okay, so left to right, increasing trend, and you have to choose the values from 0 to 4, 6, 8. You can't take 0, correct? You can't take 0.
It's 246.
Because if you are just choosing 0, that will be a 2-digit number. So you just have to take out from 2, 4, 6, 8. What are the values that you can choose out? Like 2, 4, 6 can be a 1. 2, 4, 8 can be other. What is 2, 6, 8? Is there anything that we are missing? 2,
4, 6, 8.
4. Okay, 4, 6, 8. Correct. 4, 6, 8 is also one number. Yeah, so this is an increasing wala, increasing. Then now we can have a decreasing trend also. So for decreasing, so this is for the increasing trend. Okay, now we have to take out for a decreasing trend, correct? From left to right only, but it should be decreasing. So for the decreasing, we can take anything, right?
We can reverse the same one, right?
No, we can't reverse it, but here we can take 0 also, right? So 0 can come here for so many values, right?
Yes, sir.
Excuse me. So 0 can come here. So what are the other values? So yeah, so reversing. So if we are just reversing, we'll be having 4 more.
Yeah, it will be 864.
Sir, in this reverse case, won't we be having two different cases where 0 is in the number and without 0 we'll be having some other possibilities?
In the decreasing trend, right?
Yes, sir.
Yeah, decreasing, we have 4. So we'll be having 4 extra. But apart from this 4, we'll be having more numbers. I mean, let's for example, we have to take out all those numbers that ends with 0.
Yes, sir.
Let's for example, 860 can be 1, correct? And it is on a decreasing trend. Similarly, what can be the other values? 840 can also be a 1.
820.
820 can be also one value.
862.
The total 6 possibility will be there.
862, yeah, we have already taken, right, from here. So the inverse of this. So now we have to just take out all those values where we are just putting 0 at the end. I guess all 3, and then 6. If 640, 620. I guess these are the only 5.
We can also
sir,
use
420.
420.
Okay, 420. Yeah, I guess this is the final thing. So
but
we
it's
have
mandatory
6.
to take 0 here.
Yeah, because we've already taken all the other values. So we have to take all those 3 digits number that can be created with this 5 digits, and that should be decreasing. So each digit should be in the decreasing trend. Okay. So we can take.
I'm sorry, I missed why you didn't take 0 in the increasing thing. I missed the point.
Increasing, if I'll take 0 as an increasing 2, 4, so that will be a 2-digit number, not a 3-digit number.
Oh, yeah. Sure. Okay.
Got it, right? Yeah. So now we have how many numbers that we have created? 6 plus 4 plus 4, correct? So altogether 14 numbers we have, correct? Or not? Is this clear to everyone?
Yes.
Yeah. Okay. So now for this case, for the number of digits that has been created from 1, 3, 5, 7, 9. So here we just have to create in one case and then we can double it out, right? Because here there is no problem with 1. Here it was a problem with 0, so that's why we have to split it out, the condition. So here we can just create the number for the increasing trend and then we can double it out for the decreasing trend, correct? Can you give me all those numbers with increasing trend? So one can be 135, 137, 139. Then you can have 157, 159. Then you can have 179. Okay. 357, 359.
359.
Anything else?
379.
Yeah, 379. And then you have 579.
579.
So you have 3, 4, 5, 6, 7, 8, 9, 10. So you have 10, and 10 will be, if you are writing in this decreasing trend, 9, 7, 5. Similarly, you can just do the reverse of this all values that we have created. Correct? So we'll be having 10 more. Is this clear to everyone? So altogether we'll be having 20 different digits, 20 different number, 3 digits number. Okay, so and you were asked to calculate the ratio of these two. So 14 upon 20 should be the answer. 7 upon 10. Is this clear to everyone, or do you want me to repeat it? So this was a
Yes, sir,
question
it's
where.
clear.
Okay. So if it's clear, so we'll move to the next question. Okay. Okay. So the next question is, and this you have to solve it out. We have solved this type of questions. So this is a question. Here it has been asked that 2100 distinct n-digit number has been formed using exactly 3 digits. So with the help of 1, 2, and 3, with the help of only 1, 2, 3, we have created 2100 n digits. So n digits number. So basically it's a n digit number, n digit numbers we have created, and 2100 n digits number we have created. So now can you tell me the smallest value of n for which that is possible and repetition is allowed?
Sir, can you please repeat the question?
Yeah, so what I'm saying is you have created
111. For n digit, 1111111.
No. Okay, I'll just repeat this question. So basically, you have created 2100 n-digit number. Okay, it can be a 5-digit number, it can be 2-digit number, 7-digit number, 8-digit number. 2100 n-digit number you have created using 1, 2, 3 only. Repetition is allowed. What can be the minimum number? What can be the minimum value of n? This is what has been asked. So if you are just, let's for example, I'm just giving you an idea. So n-digit number you have to create. Repetition is allowed. Okay, so if you are creating n-digit number, this is the n-digit. So what can we put it here? You can keep 1, 2, 3, all the 3 you can put it here. Right? And repetition is allowed, so you can put 3 also here. Similarly 3 here. So 3 to the power n. Correct or not? Is this clear?
It will be 3 raised to power 2100.
3 to the power?
That's what you want to say. 2100.
No. I'm just saying that this 3 to the
You are
power
asking
n.
the least value of digit, right?
Yeah, least value of n such that 3 to the power n is equals to 2100.
So, but we can use
Equal
1,
to or
2,
less than
3, and the
equals to.
lowest number is 1. So, if you can put everywhere 1, the lowest will be possible. No, we're using only 1, 2, 3.
No. I guess you didn't get the question. And what I'm trying to say is, you are creating an n-digit number. N-digit number you are creating. So you'll be having n different boxes are there. Each boxes you can put 1 or 2 or 3. Correct?
Yeah.
So with the help of 1, 2, 3, you are creating an n-digit number. Let's, for example, you are creating a 5-digit number, and that 5-digit number can be 1, 2, 3, 2, 1. This is a 5-digit number, and you are just using 1, 2, 3 only. Correct?
Yeah.
And with the help of, you are creating an n-digit number in such a way that you are able to create 2100 different distinct numbers.
Okay. So
Yes,
what can
sir.
be the value of n? So see, this is like this is what the equation you have to use. So if you are using only 1, 2, 3 as a number, and you want to create 2100 distinct languages, distinct 3-digit number with the help of 1, 2, 3 only. So each of the n digits can have 1, 2, 3 because repetition is allowed. So basically,
Yes,
you
sir.
can have 3 here, you can have 3, you can have 3, right? So how many number you can create it for n digit? 3 to the power
3
n,
raised
right?
to, yes.
Sir, 7-digit.
Yeah, correct. And that should be less than equals to 2100 because 2100 you have to create it, right? Correct. So you have been asked what should be the list n so that 3 to the power n is less than equals to 2100. I guess 7 is correct.
Taking log both the shelves.
Sir, 3 raised to 7 is 2187 and 3 raised to 6 is 729.
So, sir, should we take 6?
No, if you'll just take 6, you'll not be able to create 2100 number. You'll just be able to create 729 numbers only, right? 3 to the power
Yes, sir.
6. So you'll not be able to create that many numbers. So here you have to create 2100 numbers. So with the help of 3 to the 7 digits, you will be able to create 21. You can create more, but 2100 is the minimum number that has been asked.
Okay, sir. Got your point, sir. Thank
Correct?
you, sir.
Yeah. So you can't create with the help of 6-digit number. Is this clear to everyone?
Yes,
Yes, sir.
Okay. Let's move to the next question, and that will be our second last question for this today. And the question saying is, in 1 year, 3 positions, best, second best, and third best, will be given to a class of 25 graduate students. So 25 students are there in a class, and then there is a 3 post. Okay, you can just think of as a president, and then vice president, and then secretary. Okay, so there are 3 posts, and 25 students are there in a statistic department. That's not relevant based on their performance in the exam. Okay, so there's some, okay, it's an exam or maybe an election. So 3 posts, president, vice president, secretary are the 3 posts that can be 3 positions has to be filled. And if each students can hold at most one of the 3 positions at a time, then how many possible ways the 3 positions can be selected? So 25 students are there, 3 posts are there, and if each students can hold at most one of the 3.
25 into 24 into 23.
I guess that's a correct, yeah. Then how many possible ways these 3 positions can be selected? So you already know that one students can be president and vice president both, right? So in the first president, if let's for example you're starting with president, so 25, all the 25 students can fill this president post. So if somebody has filled, let's for example S1 has filled, now from S2 to S25 is left for the vice president, right? So it'll be left with 24 numbers. Similarly for the secretary, how many are left? 23, correct? So 23 posts are left for the secretary. So it'll be left with what? How many numbers? How many possibilities are there to fill these 3 positions? 24 into 20, 25 into 24 into 23, correct?
Yes, sir.
It's clear to
But
everyone?
it is saying that it is at most one
Yes, sir.
position. So how do we account for the fact that none of the
Yeah, so if some people, let's for example there are 25 people, right? So only 3 can hold, right? So if 3 people are holding, the others will not be holding the position, right? So this is what it's saying. If each student got it right, if each student can hold mostly one of the position, it's not that one student can be both, and it's also not.
Okay.
three positions are filled, the other 22 students will not be holding any positions, correct?
Okay, okay.
Yeah. It's clear, everyone?
Yes, sir.
Yes, sir.
Okay, now the next question is 10th one. So this thing that there are 45 games in a tournament. Some XYZ tournament is happening, and there are 45 games in tournament. Now it's saying that many. So if there are 45 teams, 45 games that has been occurring in a tournament, so many teams would have taken part in the competition, and each of them must play at least once with the other team. In how many ways how many teams took part in the competition? So basically it's pretty simple. So 45 games are occurring in all together, and it's saying that each of the teams, so whatever the number, let's for example n teams has taken part, each teams would have played at least once with the other team. So whatever, let's for example the first team, so it would have played with all the other n-1 teams. Okay, now it has been asked in how many ways the teams took part in the competition, like how many teams are there in the competition. So if there are n teams, first would have played with the other n-1, correct? Are you getting my point? Have you understood this question or
So
not?
45 into 22.
45 into 22. No, number of teams.
45 minus 1 factorial, sir.
So n into n-1 by 2. Two teams
I
are
think
will be playing again, so it will be divided by 2.
I think sir's mic is not working.
Correct. It's not
So-
working.
So I think, or maybe it's my internet issue.
Comes to around 10.
Okay, so are you able to hear me? Like my voice is audible to
So it's
everyone or
breaking.
not?
Yes, sir, you're audible.
I think there is a network issue at your side. The
Oh, maybe.
voice is breaking actually.
I think the results are released.
Yes, it shows on the portal, but like total marks.
I don't know why it shows not eligible in the course registration, but yeah, it shows eligible in the my current courses. But either ways.
So are you able to hear me now?
Yes, sir.
Okay. So what I was saying is, so I'm not able to share my screen. Just wait for some 2 minutes. Otherwise, I'll just discuss the question. So the questions was basically, so there were 45 games in the tournament, altogether 45 games, and then each team is playing with the other team. Okay. So if each team is playing with the other team, so somebody was saying, right, so if you have n teams, let's for example you have n teams, and if
Sir,
all
I
n
think your board is not visible.
yeah, correct. So Okay, so it's not because I have not been made. Okay, I just try to speak out without sharing my screen itself. Okay.
Okay, sir.
Yeah. So this question basically is there are 45 games that has been happening in a tournament, and you have to tell me the number of teams that is available in the tournament, right? That is participating, such that each of them must have played at least must play once, not at least then there will be a n number of. So each of the team has played once with the other team. Okay, if you have n teams, so how many n minus? So for the first team, n minus one teams are available. So they would have played with n minus one team. Similarly, the second team would have played with n minus one team. The remaining n minus one team. Correct. So each team. So in the IPL, normally what happens? Like now, it's not happened. Earlier, when there was 8 teams, they used to play with each team. They used to play twice, I guess. I don't know much, but yeah, they used to play twice, I guess. uh, each team, right? Now there's some other pattern that they follow when the number has increased, but earlier they used to play twice. So I'm just saying that, let's for example, there is a tournament T where each team is playing only once with the other team. Okay, so if they're playing only once with the other teams, then, and altogether the number of games that has been played is 45 only. So then you have to tell me what can be the number of the teams that is participating in the tournament. So what can be the approach? What do you think can be the approach?
So will they be playing twice?
Sir, is it a knockout tournament?
uh, Tournament can be anything. It's just that you don't have to think of as a final, semi-final, other than all those things.
So number
Just that,
means it will be n into n minus one, no? Like,
yeah, it should be n into n minus one, correct? But you have to divide it with 2, right?
because they will be
Yes,
playing twice, no? Each would be team will be playing twice.
No,
because
here it
two
is just,
teams are playing together.
So you are selecting 2 out of x number of teams, n number of teams. That's what you want.
yeah, correct.
So you have to divide by 2.
You'll have to divide
Sir,
it with 2, correct? Because,
sir,
990.
actually,
Answer will be
because
10.
see, I guess the answer should be 10. 10 into like 90 upon 2 is
10
40.
into 90, 90 divided by 2, 45.
Yeah, so yeah, 90 upon 45. Correct.
sir, I thought in a different way, but I think my approach is incorrect. But can you just tell me where I'm making mistake? Sir, I thought it in terms
Yeah,
of,
yeah, go ahead.
sir, in terms of total number of matches played, as that at every step the number of people will be, number of teams will be halved. So I made a series starting with n, then for next it will be n by 2, then again n by 4, so on till 1. So is this approach
The
correct, sir?
IPL is usually a round robin tournament. So I think we are only
Yeah,
asked to get the round to take only the round robin portion.
yeah. Can you go ahead? Like, can you? Maybe my net is not working, so that's why I'll
So
just.
So,
it
so
would be
basically, I made a GP series starting with n and ending with 1, and at every step I halved the number. So my series became n plus n by 2 plus n by 4 till 1.
No, why are you doing this?
I because I want to to calculate all the matches played till I get only one winner.
No, you don't have to think. So that is what I'm saying. You don't have to think all those cases. One winner, two winner. Let's for example, there is only 2 teams are there. Okay,
Mm-hmm.
and they have to place. And they have to. So 2 teams are there. One mine and one yours. Okay, there's a tournament, and if it is said that each of them, so each of us should have played the other team, right? I would have played with like against you, right? So how many games I can play with? Like only one, right? So if you
Yes.
just the 2 teams are there, how many games is possible?
Yeah,
Two
one, sir.
into two into one. upon 2, correct?
Yes, sir.
Right, because I can just play with you, but whenever you were adding, so you would have played with me, so both are counted, so that's why I'm dividing with 2. Are you getting me?
Yes, sir.
Got it, right? So if you have
Yes, sir, got it.
n teams are there, they would have played with n minus 1, so each of the team would have played with n minus 1, so you can add it n minus 1 n times, right? So that will be n into n minus 1, but so both of them are counting, right? So one is counting if one is playing with the fourth team and fourth is playing with the first team, so both are been counted, so we have to divide it with 2, correct? So that's why we have to divide it with 2, n into n minus 1 upon 2, that will be your correct number of games that will be played in the entire tournament.
So basically the handshake problem, sir.
Correct. Yeah, that's the correct approach. Yeah. So there also you use it n into n minus 1 upon 2, because both of the people are, if I'm handshaking with you and you with me, then both are same one. So basically you have to divide it with 2. So here
Yes, sir.
also that's the same approach you have to
I got your
go.
point, sir. Thank you, sir.
Okay, so I guess my net is also not working, and we have thought of discussing till 10. So we have discussed. If you have some
Tell me
any
how to identify whether it is a clockwise or anti-clockwise are same or not. Any question, any example you can give?
Mostly it will be given in the question. So if the anti-clockwise and clockwise are same, or if you are dealing with the questions related to some flower blossom or with the necklace, those type of problems, because if you'll just flip the necklace also, you'll be having the same, okay, so same pattern. So
There
that's why in
was
those
one
cases,
question like a practice assignment where beads could be same. Suppose they are all identical, then what would be the rule?
yeah, so this is what I'm saying. So I guess the same problem you're dealing, like the necklace problem, right?
Yeah.
So in those cases, it will be always be the anti-clockwise and the clockwise will be same. Okay, but if you are just arranging some people, okay, so in those cases they can't be same. So there, if it is mentioned, then only you should be solving with taking the clockwise and anti-clockwise as same. Otherwise, you'll always be taking as a different. Okay. So arrangement or putting something, so all those cases you'll have to take it as a different case.
Okay.
Yeah. Okay. Any other doubt? If you have, you can just ask me. I'll not be. I guess I just asked them to make me the code, but I'm not. But okay, that's
Excuse
fine.
me, sir.
Yeah.
I have the doubt regarding quiz 2. In quiz 2, which week syllabus questions will be asked, sir?
Yeah,
Uh,
that's
week 5 to 8 will be asked.
Only
but
these
sir,
will
4
that is
not
weeks, sir.
be
for
so
no, but sir,
till
that
week 1 to week 4 we will not be like asked questions on it.
no, sir, but I think that is for those students who want to give it willingly. For those who are giving